Today we're going to talk about AI in the form of large language models such as ChatGPT and Copilot, and how we might leverage their use, how we can create prompts and open the conversation up to exciting developments in major concerns that we have, such as faculty refusal to allow the use of AI, cheating and critical thinking issues, and much more. Before we take a deep dive into ways we can leverage AI in our daily work, it's worth some time to take a step back and look at the bigger picture. There's a feeling that AI tools themselves are evolving so quickly that it feels difficult for us to keep up. A lot of the online exploration of AI that appears in blogs and in YouTube videos, they focus on trends, and in order to understand that conversation, we need to consider change, or more specifically, rates of change of information technologies, those technologies that deal with the creation, storage, processing, and transmission of information. Some technologies seemingly explode onto the marketplace, like the smartphone, whereas others, like fully self-driving cars, seem to languish for years. To better understand trends and the rate of change, I'd like to start with a story that helped me in my attempt to get my head around the concepts. It's a story about grains of wheat, or you may have heard variations of this story, whether it was rice or seeds. It's essentially the same story. It helps explain why predicting our technological future is difficult, but not impossible to track.
In the heart of ancient India, a rich and powerful king ruled over a vast kingdom. His fascination? The game of chess. Yes, chess. This mind-bending game of strategy and wit, invented by an old man within his own kingdom, had the king utterly captivated. His admiration for the game grew so much that he desired to meet its creator, a humble old man, to thank him personally for his genius invention. He wanted to reward the old man for creating such a captivating game, a game that challenged his mind and stirred his competitive spirit. And so, the old man was summoned before the king, ready to ask for his reward. Standing before the king, the old man made his simple request. Wheat. With a glimmer in his eyes and a steady voice, he proposed his unusual terms. For the first square of the chessboard, give me 1 wheat seed. For the second square, give me 2. Continue doubling the number for each subsequent square until you reach the 64th. The king was taken aback. A request for wheat? And such a small amount at that? His surprise quickly turned to irritation. Such a trivial request seemed almost an insult to his vast wealth and power. But he had given his word, and so he nodded, saying reluctantly, "Very well, your request shall be granted by tomorrow." With a heart full of gratitude, the old man thanked the king and departed, leaving behind a room filled with intrigue and confusion. The king, puzzled but committed to his promise, awaited the final count of wheat. The next day, the king's minister, mathematician, and steward revealed the impossible task. The sheer magnitude of the old man's request had come to light. It was a number so vast, so colossal, that it surpassed the king's wealth and the kingdom's resources. 18 quadrillion, 446 trillion, 670 trillion seeds, they said. That's 848 trillion, 550 billion kilograms of wheat, more than 1,000 years worth of the world's entire wheat production. The king was taken aback. His pride had been shaken, his arrogance shattered. He had underestimated the wisdom of the old man, mistaking it for a simple request.
So let's explore the topics of exponential growth and how we actually think, which is linearly. To distill it down in terms of our work today, here's an example of linear thinking. As an ID, it took me this long to develop a presentation this year, so next year it'll take me the same exact amount of time to develop the exact same type of presentation. Well, if AI continues to develop exponentially, that's probably not going to be true. 3 weeks ago, Peter Diamandis and Niels deGrasse Tyson had a conversation. Diamandis is known for the X Prize Foundation, which hosts competitions to spur technological innovation. Tyson is a renowned science communicator. Here they discuss why, when planning involves exponentially changing technologies, it is so challenging for us. As we said before, it's challenging because we are linear thinkers. Here, take a listen.
Our brains are wired for linear thinking in an exponential world, and it's causing us a great deal of strife.
This linear thinking prevents you from realizing a possible future that awaits you. This is a rich country. We can do whatever we want if we all agree to it. So it's really not a matter of a budget, it's a matter of what is motivating us. 1908, the quote, "Man will never fly from New York to Paris." 1908, you know who said that? Orville Wright.
That's my favorite request on stage. Can you give us a prediction for 2050?
We will have designer drugs. They'll analyze your genome, find drugs that will have no side effects for you. All cars on the road will be self-driving electric. The entire solar system becomes our backyard.
And the only thing we know about these predictions are?
They're gonna be wrong.
Yes.
Yeah, it's understandable that we have linear brains. Why would it be anything other than that? Think of, we evolve on the Serengeti or wherever, and you just don't want to be eaten by the lion. That's not exponential thinking, that's very linear thinking.
Can I get to the tree before the lion gets to me?
That's linear, that's a linear exercise,
linear, yes.
Okay? The speed of the lion is not increasing.
Yeah.
All right? Ad infinitum.
Luckily.
We'd have to have a different brain to understand that.
Yes.
So I don't want to fault us for thinking that way, but to have self-awareness can bring you great benefits. If you know in advance you have linear thinking. And probably the cleanest example of the failure of our brain to understand exponentials is the one that involves a lake, and there's algae growing on a lake. And you see it there, and you see that the area of the lake covered by algae is like doubling every day. Like it starts out in a little patch, and you come back the next day, it's like twice as big. The next day, it's twice as big. So that's kind of scary.
That's classic exponential growth, the simple doubling.
Yeah, doubling,
Yes.
correct. So the question is, you're there and you go away for a month, and you come back and the lake is half covered with algae.
Your favorite lake, it's awful.
It's half covered. So the question is, how much more time do you have to wait for the entire lake to be covered? And okay, you all are smart in here, that's what I'm saying. Most people say another month. That's linear thinking. No, the entire lake will be covered in one more day with the doubling per day. And that's perhaps the simplest example of this.
So exponential change results from rapidly developing technologies driven by exponential hardware improvements, such as Moore's Law, and software improvements, such as in the case of AI. In education, virtually all the innovation is occurring online using digital technologies. Along with the integration of AI, digital technologies offer personalized learning and interactive simulations with immediate feedback. In fact, if you project just a bit further, it's not hard to imagine a future where online learning takes place in an interactive, immersive environment and in simulations of all kinds. Here are 3 converging trends that are currently impacting education. The first consists of the broad swath of exponentially changing technologies giving rise to entirely new fields of study such as synthetic biology, molecular engineering, computational biology, biochemical engineering, computational social science, and AI robotics, and on and on. Exponential advancements are profoundly impacting education in several other ways. For example, AI-powered simulations offer immersive and engaging synchronous learning environments that enhance understanding and retention. Today, as mentioned before, all innovation in education revolves around these kinds of digital technologies, impacting both on-ground and online learning. AI is blurring the lines between synchronous and asynchronous learning, the traditional rule of avoiding live elements in online courses, which would rely on immediate feedback rather than the delayed feedback that is currently in our asynchronous courses, is being challenged as AI enables real-time interaction. Asynchronous learning is becoming synchronous learning as time goes on. Also, there's a trend towards people becoming physically closer and closer to the information they need at any given time. We've moved from library catalogs and browsing book stacks and microfiche to computers, to laptops, to smartphones, to watches, and now to smart glasses with AR capabilities. These AR glasses overlay data on top of the real world. The glasses are already connected with AI systems and already produced, and directly feed audio into our ears. It will be just-in-time delivery of information whenever we need it. Personalized learning is next. Finally, the trend of personalization of all content, whether it's entertainment on devices, whenever you want, and wherever you happen to be. It's obviously happening now. It's been happening for the last 10 years. Also, advertising, where the products you search for seemingly follow you around from one website to different devices, reminding you of your interest in purchasing it. And a possible dystopian future soon that might appear on your AI glasses. Hopefully not, but let's take a look.
Olvídalo.
Estoy presente ahora. Me amo. Estoy libre de mi ira. Estoy libre de mi tristeza. El amor es mi tren.
Adiós.
Olá, eu sou Maria.
That video was made about 8 years ago. It's pretty astounding. Anyway, the AI systems will soon be integrated more and more within LMSs. They will provide instantaneous feedback to students within these systems and generate educational simulations on the fly, offering immersive and engaging learning environments that enhance understanding and retention. I took a photo of a refugee camp from Masha 599, and what it did was, I didn't know what it was going to do. I thought it might fly through this still photo, but instead it pans the photo and animates the people within it. The only thing I think it did wrong was there's a bear at the bottom right corner. I think it's a bear. I don't know what that is. But aside from that, that was pretty good. And you could see how if it starts to model things and animates you through environments, now you have the beginnings of a simulated adventure even that can make its way into our courses. So this is OpenAI's roadmap for AI development going forward. Most of the AI industry seems to be following the same or a similar roadmap. Stage 1 or level 1 are chatbots, AI with conversational language. and we've already seen that. Stage level 2, reasoners, human level program solving. And basically that is what's being introduced more and more into the into the LLMs that we're using on a daily basis. For example, this down at the bottom of the screen is a notice I received on the day of the presentation, in which it's notifying me that the O3 mini family was available, and it stated that the O3 mini and mini high are two new reasoning models that excel at coding, science, and anything else that takes a little more thinking. So it's considered a reasoning program, one that will iteratively reconsider its initial output to double check it and also to consider it from different perspectives before it offers it up to you as a solution. Next stage, we have stage level 3, agents. And the agents are coming right now for us.
Mr. Anderson.
No, not that agent. Not that agent.
Agents are emerging as the latest battleground in enterprise AI.
We're gonna bring a level of automation capability that the world's ever seen, and I love that you codified it as agent.
The second, which we've just reached now, is reasoners. The third is agents.
And we're not stopping there. And today we're introducing new agents. And the project I've been staying up late every night working on for many moons this year is Agent Dive.
So I think we're going to live in a world where there are going to be hundreds of millions and billions of different AI agents. Eventually, probably more AI agents than there are people in the world.
So what exactly are AI agents, or commonly referred to as agentic systems?
AI by itself is like raw brain power. It's got all this potential, but it's not really useful until you give it a job. Enter the AI agent. Think of AI as the genius with a million ideas, and the AI agent is the one who actually gets stuff done. While AI is all about smarts, an AI agent is the practical, hands-on version. It's like giving that genius a task and saying, okay, now go do something useful with all that brain power. The AI agent takes the intelligence of AI and turns it into action, whether it's answering your questions, automating your work, or handling your to-do list.
Here's Microsoft CEO Satya Nadella explaining how he envisions AI agents will be used by us.
Full interview down below.
SaaS applications or biz apps. So let me just speak of our own Dynamics thing.
Right.
The approach at least we're taking is, I think the notion that business applications exist, that's probably where they'll all collapse, right, in the agent era. Because if you think about it, right, they are essentially CRUD databases with a bunch of business logic.
Okay, I'm going to pause there because what he just said might sound like no big deal, but it is actually a stunning proclamation of the future. What he essentially said is that SaaS, and that means software as a service, is essentially just a thin UI layer on top of a database. And when he says CRUD, that means create, read, update, destroy. Those are the base units of interactions between an interface and a database. So create a new record, read, extract information from the database, update, make a change to an existing record, and destroy, delete. So all he's saying is there's going to be the underlying database, the fundamental data of what you need, and then it's going to be agents that are interacting directly with the database. And if you've been watching this channel at all, you know I've been talking about this for a long time. I truly believe the entire application stack is going to disappear. There just really is no need for it when you have artificial intelligence interacting with the core grounded data that sits within a database. And again, what does that actually mean for the entire SaaS industry? What does that mean for application developers? I don't know exactly, but I have a feeling it's going to look vastly different than it looks today. And I've been in SaaS my entire career. I have built multiple SaaS companies. I've worked for SaaS companies. And if I'm being transparent, I probably wouldn't start another SaaS company right now. And I probably wouldn't invest in any SaaS companies right now either. It's just too unknown. Now, that isn't to say there won't be software companies in the future. It's just going to look drastically different.
You need to actually execute on those steps yourself. You need to click, type, swipe, drag. All of the steps you need to execute yourself manually. So while we've built these incredible automation machines, we're still operating and controlling them like some factory workers from the 1800s. And AI agents are about to change this forever. What we're about to witness is actually a continuation of a trend in computing that's been building for the past 70 years. All computers, from your smartphone to your laptop, are limited by one thing. And that's how fast we can tell them what to do. We can call this the input bandwidth of a computer, how much information we can feed into it through clicks, swipes, keystrokes, and gestures. Let's look at this trend throughout history. Starting off in the 1940s, the first computers used switches, and imagine you had to flip dozens of switches just to do some basic math on them. So you could manage maybe about 10 inputs per minute as your input bandwidth. In the 1960s, keyboards arrived, so you could now type commands directly into the computer, but you had to memorize them like some kind of secret language. And so the speed of input jumped up to maybe 40 per minute. And then in 1984, the Apple Macintosh brought us point and click and graphical user interfaces. And so with this keyboard and a mouse, we could finally hit, say, 200 inputs per minute. Then in 2007, the iPhone made computing portable. But despite having touchscreens, we're still stuck at around 200 inputs per minute. So for the past 15 minutes, we haven't gotten any faster at talking to our computers. We're still limited by our fingers. And even Elon Musk sees this as a painful limitation for humanity.
The rate at which we can type words into a phone or a computer, it's very slow. Our input is much better because with the data rate from vision is many thousands of times, maybe a million times better than the rate at which we can output.
So if you view custom GPTs in the light of their more developed AI cousins, agent cousins, you can see the movement towards simplifying of our output and offloading the task to AI. We still need to create fairly detailed prompts in order to obtain useful outputs, but now AI can rewrite the prompts and be more accurate and complete. And we can then create custom GPTs that even simplify things more. They're narrowly focused, that can do one thing you require, but it needs drag and drop inputs from a still. It's not an AI agent, but it's kind of a mid-step towards that. And AI agents will take it all of the way without our constant attention. So at this point, I'm going to show the survey results in our course builder, and in this presentation, you can click on the graph and it'll bring up some results, and you can look at them. So that's kind of enjoyable, but I won't continue with that right now in the effort to keep this video to something of a reasonable length. And now prompts. One of the most basic skills needed in generative AI and large language models, such as ChatGPT, Copilot, Claude, Gemini, Perplexity, and all these others, is in creating an input called a prompt that obtains a desired output. The entire industry has been created called prompt engineering. So So what is a prompt? A prompt is a carefully constructed input provided to a large language model to guide its response or output. It serves as the initial instruction or context that tells the model what kind of information, task, or style or task to focus on. Be very specific about the instructions and tasks you want the models to perform. The more descriptive and detailed the prompt is, the better the results. It's not so much science, it's almost an art. You have to practice at it. You'll have to go back and retweak the results. And if you do not obtain the results you need, it's best that you provide an example of the needed output. It goes a long ways towards that end. Request that the LLM create the prompt. That can also help a lot. At the bottom, I have two resources down here. The Prompt Engineering Guide, which is very useful, shows you examples of different kinds of prompts, and the LDC General AI in Education repository that will house a lot of our information, including a lot of information on building custom GPTs and building prompts, etc. Finally, one more thing about building your prompts. Try to always begin with acting as an expert in the field of, or acting as an expert instructional designer, if that's what you need. And talk about it's for the creation of online master degree level courses, that type of thing. Always helps. And more information that you add, again, the better the results tend to be. So what comes next after custom GPTs? As we mentioned, AI agents are what's coming, and a few have been released very recently for public use already. The AI agents, early use cases include doing things like automatically filling out online forms, making dinner reservations, not something we do all the time. Do web searches though, products, services, collect research for you. Those kind of simple tasks are what they're doing now. And there are three that I came across that are in primary use. Browser use is free. It's a Swiss product that you can control your browser, and it can control your browser and fill out forms, navigate websites, and simulate human input, which is fascinating and scary. But that's what they all do. OpenAI Operator also can perform tasks using your computer, mouse, and keyboard similar to humans. Navigate web pages, click buttons, fill out forms, input text. And Claude Computer Use. Computer Use is the name, and it can also do the same thing. So those three are in very common use right now. In our work, we can imagine some pretty good useful uses for agents. For example, rather than waiting for Canvas to integrate AI to complete rubrics and program them into the LMS, an agent can learn how to do it and complete them while you work on other matters requiring higher order thinking skills. Wouldn't that be nice? Okay, we're almost done, but there's some of these pesky issues that we need to discuss in the next sessions coming forward, including here, hopefully, critical thinking, ethical use, faculty and AD resistance, and more. Well, critical thinking is likely to take a huge hit from the converging trends mentioned earlier. Proof of that has been out there for some time. We used to remember phone numbers, but now we voice dial on our phones, in our cars. We don't really remember phone numbers much anymore. We use GPS, and we don't really learn the routes as well as we had in the past. And now, as featured here, there are studies that show that offloading of our critical thinking skills to AI results in lower quality thinking. So you can click on this paper and it'll take you to the actual article. So here's one educator's response to the challenges of AI generally, and AI agents specifically, and what they pose to education. He's an on-ground faculty member, so some of his ideas don't directly apply, but it's fertile ground for us to think further on them. Based on some of his comments, perhaps we replace transcripts in select video presentations, and not tip off, AI agents that, this is what the video is about. So far, AI can analyze YouTube videos, but they can't go off and do Panopto videos, for example. So if we had a special presentation, we could put transcript available upon request down below, so students can't just copy the transcript into a
these things, we need to ensure that we are using effective pedagogy and effective instruction we're not going to be able to prevent the use of AI, but so that we can properly ensure that we are thinking about it and incorporating it in the right way. I've talked many times before about my share technique, where we're using different ideas to help ensure that the student is using AI appropriately and we're teaching effectively as well. So one of the things would be that we would ground content, meaning that there would be lots of things going on in the class, and we would refer to that as part of the questioning, as part of the assessments, meaning that if we had something like a special presenter, well, then our questions would be geared towards that, meaning when the presenter talked about XYZ, what did the presenter mean? Or what did you interpret this? Or when we had a demonstration in class about this, what were the results? Things that an AI wouldn't necessarily fully understand. So the idea here is that you ground the information, you make it in such a way so that the student now has to be more active in the actual presentation of their knowledge of what they're doing for those assessments, as opposed to just ABCD about questions and knowledge that an AI would already know. So that's the idea of grounding the information more specific to your course. So that makes it a bit more difficult. The student has to be more involved. Also be thinking about aspects as far as, well, let's use more video assignments or video turn-in or presentations in class, more things that would hold students accountable for their learning, as opposed to just having them use an AI to fill out everything because of this hygienic capabilities. So that's just the big thing that I want us to think about here when we're talking about students and their learning, is that we need to hold them accountable for what they really know. That doesn't mean that we don't want them to use AI, because we do for certain things. Why? Because now let's go full circle and go back to how businesses are using this. If a business is using this, then that's going to be what that business is expecting that student to be able to do when they get the job there. So we need to ensure that we're developing their capability to use agents. What about managing agents? If there's a bunch of agents that a student needs to use in their job, they need to learn that capability. They need to learn that skill. So we need to be thinking about, okay, how can we incorporate, how can we have them use agents to do something, because we want them to learn that skill, that process as well.
So critical thinking will take a hit. And so this is his document that he shared. If you click on it, you'll see a full screen version. You can print it, download it, and consider it as part of our process in kind of hardening our assessments against just wholesale AI use. So this is the end of the presentation, and but perhaps the beginning of our discussions in what we have to do going forward. There's just a partial list of considerations of possible agenda items, perhaps for the next meeting. One is, again, ensuring critical thinking and assessments. It's my hope, I think we agreed, that perhaps a repository on Notebook or some other knowledge base approach to everyone pitching in how they've created assessments that can be hardened against AI use or encourage critical thinking, that type of thing. And how we can enhance engagement using AI. A particularly exciting development was brought to our attention from Heather Smith and Serena, and in having this, in showing us this Notebook podcasting capability. And so I had taken that paper that was critical of over dependence on AI and reduction of critical thinking, and I converted that in that different format, in that podcast format. And also, one thing to add is even more exciting is potential use in our courses, is that a student or you can actually join into the conversation of that podcast. So if you make a comment, they will pause and say, oh, we have a listener with a question who wants to pitch in. What do you have to say? And so here it is. Here's how realistic it sounds if you haven't heard it before.
Hey, everyone, at the University of San Diego's Learning Design Center. You know, it's your host here. And well, we're diving into some research today that I think you'll find particularly interesting as you're designing those master's level online courses. We're looking at an article today called Increased AI Use Linked to Eroding Critical Thinking Skills. Kind of a head scratcher, right? I mean, we're all grappling with this rapidly evolving world of education, and AI is a big part of that. So let's unpack this. Let's unpack this together.
Yeah, it's definitely a hot topic right now. And this article really digs deep into a study that found a pretty strong link between using AI tools more and a drop in critical thinking skills, especially in younger folks. Definitely something we need to be paying attention to, especially as we're, shaping the minds of future leaders.
Yeah. When I saw that headline, I was hooked. What really caught my eye was how this study didn't just look at a small group. They had like 666 participants from all walks of life across 3 different age groups in the UK. And get this, they didn't just do surveys, they also did these in-depth interviews. It's like they really wanted to get the full picture.
That's what's so cool about this study. It's like it uses what they call a mixed methods approach. And that gives us a much better, much richer understanding of this issue.